All right, example 6, we have another function. We're going to find the following. So x-intercepts. So the way I find x-intercepts is I take my numerator and set it equal to 0. It's a quadratic, so I'm going to factor out a 2. So I have x squared minus 4 equals 0. And then I would go ahead, difference of squares. So I have x plus 2, x minus 2, 0. I would set all the parts equal to 0. When I take 2 and set it equal to 0, does that give me any information? Or is that even a true statement? Does 2 equal 0? No, so that's a false statement. So we don't get any information here. But when I take x plus 2 and set it equal to 0, I get x equals negative 2. And then the other one, I would get x equals positive 2. So those are my x-intercepts. Vertical asymptotes, remember I always check for holes first. So let's go ahead and do that. To find our holes or check for holes, I would have to factor it. So I have 2, x plus 2, x minus 2 from my work from finding my x-intercepts. And then got to multiply to 10, but add to 7. So what do we got? X plus 2 and x plus 5. My x plus 2 would cancel. So I do have a hole. It's wherever they cancel. So I would have x plus 2 equals 0. So x equals negative 2. So there's where my hole is. And then vertical asymptotes, whatever left on the bottom after I do my hole. So at x plus 5 equals 0. So at x equals negative 5. So that's where my vertical asymptote is. I see I have a vertical asymptote at x equals negative 5. So I'm going to go ahead and graph this to figure out if I'm going to positive or negative infinity since I have that asymptote going on. So we're going to grab our calculator, go to y equals, clear out what we got, and then we type in our function. So we got 2x squared minus 8. And then we got x squared plus 7x plus 10. And I will graph this. And we are looking when x approaches negative 5 from the left and the right. So same thing here. 1, 2, 3, 4, 5. So here's my asymptote at negative 5. And I could zoom out if I wanted to see that it gets a little bit closer. But the first one is x approaches negative 5 from the right. So my right-hand side would be this curve. And if I follow it, we're going to go to negative infinity. So this one's negative infinity. And then I would approach negative 5 from the left-hand side. So here's negative 5. And from the left, I'm going to go to infinity. So that would be infinity. Okay. And then we got our limits as we go to infinity. So let's go ahead and do our work for this one. My biggest degree in my denominator is x squared. So I'm going to divide everybody by x squared or factor out that x squared term. Okay. So I'm factoring out an x squared. So I'd have my limit as x approaches infinity. I would have x squared in the front, and then I would write my reduced form. So I'd have 2 minus 8 over x squared all over, taking out x squared again here. X squared over x squared is 1, plus it'd be 7 over x, and then plus 10 over x squared. And now, whenever you guys have, well, before I jump to that, let's cancel out our x squareds. So I got my limit as x approaches infinity of 2 minus 8 over x squared, all over 1 plus 7 over x plus 10 over x squared. Now every time we have a number over an x to any power, that approaches 0. Okay, so this, when I plug in infinity, approaches 0, and this would approach 0, and this would approach 0. So when I do that, I would be left with 2 minus 0 over 1 plus 0 plus 0, which gives me 2. Okay. And then I would just think if I were to plug in negative infinity, those would approach 0, so I would be left with the same result. Okay. And I can check this on my calculator again. It kind of looks like it. You guys just might want to zoom out a little bit. So I'm going to hit zoom and zoom out, number 3. Do it at my origin. And then what we can do here is if you take and go over, I'm sorry, my calculator is running really slow today. There's a little bit better. Oh, I didn't hit trace. Hit trace. Make sure you do that. I go all the way to the right. and continue to hold this, you guys should be able to see the y values. We'll get closer and closer to 2, but it's going to take a while, and my calculator is just running super slow today. You'll be able to see that it approaches 2. You could also have checked it going to the left-hand side. Okay. So you can always use your calculator to kind of help you. The other thing you guys can do is go to your table and put in an extremely large value on your table. So if I go table, and I'm going to just go ahead and say, yeah, it would give me a y value of 2. So it's saying we're getting really close to 2. And so that means it's a horizontal asymptote, and horizontal asymptotes are written y equals 2. So there is that example.